In this video, we're going to graph linear inequalities in two variables using this first method, which is the one that we kind of used in the intro video um, that I kind of call the test point method, using test points. Okay, so in order to employ this method, we're always going to take our inequality and we're going to turn it into an equation. One of the nice things about this method is that it makes it so you don't have to worry about things like, you know, do I need to switch the direction of my inequality and that sort of thing when you're solving for y, because the inequality is not there. You replace it with an equal sign. So we'll get y by itself. And then we will divide by -1 on both sides. So y is equal to positive x minus 3. So this is one where we have a slope of 1 over 1, right? 0, -3 is the y-intercept. So I'm going to graph this line. However, whenever we have a strict inequality without the equal sign underneath, we're going to use a dashed line. And that reminds us that we're not ever going to allow ourselves to actually be on the line, right? Because we can't have it be equal. It's got to be greater than 3. So I'll go to my y-intercept of 0, -3. And then we have a slope of 1. So up 1 over 1. And then I'll fill all this in, but make it a dashed line. Right? And then the test point method says pick any point except one that is on the line. So pick any point not on the line. Right? For me personally, I always like to pick 0, 0 as long as it's not on the line. So I'm going to use 0, 0 as my test point. So 0, 0. And what I'll do is I'm going to take x minus y is greater than 3. And again, I'm going to go back to using the inequality, right? Even though I dropped it here to figure out what the line should look like. Now I go back to the original, and then I plug 0 in for x, 0 in for y, and I ask myself, is that a true statement? Well, that is clearly a false statement. And so what it tells me is that I should shade on the side of the line opposite of my test point. Okay? I want to shade on the other side of the fence. So this is what the graph of my inequality would look like with that side shaded. All right. So with that method, why don't you press pause, see if you can do this one yourself, and then press play again, and then we'll see if we get the same thing. So we'll start by plugging an equal sign in instead of the inequality. We'll get y by itself. Y is equal to -3/2 x plus 6. Okay, so we can go up 1, 2, 3, 4, 5, 6. And then we have a slope of -3/2. So that means I'm going to go down 3, right 2, down 3, right 2, down 3, right 2, down 3, right 2. So because I'm using an equal sign underneath the inequality, I'm going to use a solid line when I graph it. There's my line. And again, I can pick any test point I would like, um, but often we find 0, 0 a really nice one to pick, as long as it's not lying on the line. So we'll say 0, 0 is our test point. So going back to the original, 3x plus 2y is greater than or equal to 0. So 3, or sorry, greater than or equal to 12, excuse me. I don't know where that 0 came from. Greater than or equal to 12. So 3 times 0 plus 2 times 0. Does that make this a true statement? 0 greater than or equal to 12? No, that is once again false, right? And so that means don't shade on the side with the red dot, shade on the other side. All right, now here's one where it's so simple looking, maybe it becomes a little confusing. And that is when we only have x, right? But remember, we can turn it into x equals -3. And so remember what this means in terms of graphing. It's that x is -3 no matter what y is. So that turns out to be a vertical line at -3. And we'll go ahead and do a dashed line, right? Because there's no equal sign underneath of the inequality. All right. I can grab my test point once again of 0, 0. So and there's no place to put a y value, but that's okay. We just put in what's there. So x is greater than -3. So is it true that 0 is greater than -3? Yes, that's a true statement, right? And so that means that the red dot this time is on the correct side of the fence. And so we shade in the entire side that the dot appears on. All right, so that's method 1, using test points. So I'm going to record another video with the same examples showing an alternative method. And so what I would suggest is definitely watch that. Even if this is making sense to you, watch that one, decide what method you want to use moving forward. And then as we do more examples in future videos, then maybe you can just kind of stick to one or the other as you're taking your notes.